after I posted some comments in some of the YouTube videos regarding height adjustable bed for the K40 laser cutter. Um, People asked me to post my design, which I made, which is completely revamp of other stuff that I saw online. Just because I was not so happy with what the other have done. First of all, I've made this design flexible in the way that the bed can be uh, sized the way you want in your design itself, just by cutting the aluminium bars that you see here. These bars in the top is a 15 mil aluminium bar. The bottom one is a 20 mil aluminium bar. That gives a little bit more stability. The motor mount on the K40 is usually on the left hand side. Here you see it on the right hand side because of the way the picture was taken, or the video I should say later. Um, Most of it is 3D printed or can be bought directly in the hardware store. The motor mount is attachable to the 20mm rod and will be flat on the table itself, on the bed itself, in the K40 laser. Um, the the belt will have just enough space to go underneath this this top bar here. You can detach the motor mount from the bar to get it into the cutter without having to remove the gantry itself. Um, the the tension rollers here are flexible as well, not the roller itself, but they're mounted on a 3D printed part, which can be adjusted via a set screw, so you can tension the belt after you've put everything into the system itself as well. This allows for a easy way to adjust the bed if needed as well. You just release the tension, you adjust every four corners, and you can reset the tensioner of the belt system. Why I've done it this way? Because I had a closed loop belt laying around, which I've used for this proof of concept, or beta version, however you call it. It allowed me to use that belt and later decide if I want to go for a bigger bed or not. I would just need to adjust the tension system itself. Of course, you might say the tension system is underneath the laser, um, but that can be sorted very simple as well with a cover over that part. It should be very simple to do as well. A short demo. I'll start the video. The movement is very smooth, and that's basically due to the way that a stepper works. That's one. It's very precise control. I've got a very small pulley 3D printed on the stepper itself, and both the rollers and the pulleys on the rods are a lot bigger. That gives a nice high torque as well as a very fine control over the movement of the axis. As you see, this is really a beta version. It's not nicely cut. The rods. I just had them laying around more or less, and I made this one work to fit into the stock K40 without having the vent cut out. The vent in my K40 is completely removed as well, uh, by now that is, and makes it even better to work with this system. The bed itself, as you see it here, is like 20 by 30, which is more or less the standard size of the K40. Due to the fact that the rods do poke out a bit, you will have a little bit of reduced workspace itself. I've got a whole aluminium frame that I can put on here that will just fit snugly on, allowing for good engraving. And I got a pin bed that I can put on here as well, that I use for cutting. One more time, let the video continue here. This is the controller board, a standard ESP32. I've used a standard stepper driver here, nothing special. Soldered it all up. I use a buck converter, which is set to 3.3 volts to power the ESP32. The ESP32 can be run straight to the V-in pin using the 3.3 volts. The 12 volt is also connected then later on to the stepper. Of course, you could use 24 volt if you want to, if you want to run higher currents. That way you could technically get the power directly from the power supply of your K40. I decided not to do that as I want to have it as a separate control box, which you can just plug in a 12 volt power supply. I suggest to use a 3 amp power supply minimum, just to make sure that your steppers while turning do not underpower your ESP32. For that part, for the ESP32, I'll show a little bit about the website that comes with this. It's a small, simple design. It is meant to run on a 7-inch HDMI touchscreen that will be connected to a Raspberry Pi, which I will connect onto the lid of the K40 above the control panel, where you can set the direct height of your nozzle, or go directly via the pull down menu. The first position, by the way, is not ready yet, that part of the website. You can set up or down how much you want to move. As you see, this works like a charm. The positions are reported back from the ESP to the website using WebSockets, nice and easy. You can set the settings of your complete system, how much microstepping you want to have, etc, etc, etc. It's easy controllable. Over the air upload of a new firmware. This is all done in Arduino. Things to come is the installation of the time of flight laser in a laser cutter. Makes sense. That will allow for a very fine control of your nozzle height towards, or actually of your bed height towards the nozzle. After a initial calibration, it will always be very precise in the 0.1 millimeter range easily. That's it for now. I will keep you guys posted and girls on any progress I make with this, depending on the workload that I've got in my real life job. I hope to finish this up before the end of June, hopefully. Thanks for watching. Give it a thumbs up if you like it, and see you next time.